Hello dear students, this is grade 11 mathematics lesson on unit 6 matrices and determinants. In today's lesson we focus on multiplication of matrices and determinants of 3 by 3 matrices. So after revising this lesson you are expected to multiply matrices and determine the determinant of 3 by 3 matrix. Now let's continue the lesson. Two matrices A and B can be multiplied, or we evaluate the product AB if and only if the number of columns of A must be equal to the number of rows of B. And if this is not happened, we cannot multiply AB. So to multiply two matrices A and B, the number of columns of A must be equal to the number of rows of B. And the operation is done by row by column in such a way that each element of the row is multiplied by the corresponding element of the column, and then the products are added. So let's see this concept through example. Let's take this one. Let this one is matrix A and this matrix B, and we are asked to calculate A times B. Can we multiply these two? Let's see the size of this matrix. This matrix has 2 rows and 3 columns. This is 2 by 3 matrix, and this one it is 3 by 3 matrix. Therefore, the number of columns of the first matrix and the number of rows of second matrix are equal. Therefore, we can multiply A and B. So we can multiply AB because the number of columns of A is the same as the number of rows of matrix B. So let's see how to evaluate this one. AB is equal to the first matrix times the second matrix. To multiply these two matrices, we do row by column. Simply, the first row multiplies this column, not on this one, and again this row multiplies this column, and this row multiplies again the third column. So we multiply in this procedure. Let's see this one. Look, the first row A11, A12, A13 multiply this one. A11, A12, A13 multiplies this B11, B21, B31. Not only this one, this multiplies the next column, and this multiplies the third column too. This for the first row part. For the second row, again, the second row also multiplies each column. Therefore, this first row multiplies the first column, and this row multiplies the second column. This row multiplies the third. So let's see how to evaluate this one. Since the product of these two means A11, A12, A13 multiplied by B11, B21, B31, this equal to, it takes the product of the two, A11 times B11 plus A12 times B2 1 times A1 3 times A3 1. So we multiply this by this one, by this one, and this by this. So, and you add the result. So using this concept, the product of the two will be this: A1 1 B1, A1 2 B2, A1 3 B3 1. And the product of the two will be this: it is A1 1 B1 2, A1 2 B2 2, A1 3 B3 2. This one, you add the product. And for the other part, A1 1 B1 3, A1 2 B2 3, A1 3 B3 3. You get this one. Similarly, you can do for the second row. So you will have this. Now this is the procedure how to multiply matrix. Now let's see example for this concept. Now let's take two matrix A and B, where A is this 2 3 minus 4 1, and B is this 0 3 minus 5 1 minus 2 and 6. Then you are asked to calculate AB and BA. First, let's try to find the product of A and B. So to find A times B, we need to check the number of columns of A must be equal to the number of rows of B. Matrix A has 2 columns and matrix B has 2 rows. So we can multiply AB. Therefore, the product will be done in this form. AB is equal to the product of the two matrix, and the product is done by row by column. So this 2 3 multiplies the column. 2 3 multiplies 0 1. Again this 2 3 multiplies 3 negative 2. Again this 2 3 multiplies minus 5 6. Not on this one. In turn, minus 4 1 multiplies this row. This row again multiplies each column. So minus 4 1 multiplies 0 1. Minus 4 1 multiplies 3 minus 2. And minus 4 1 multiplies this column, and this minus 5 6. So the product will be the product of these two. Just 2 multiplies 0, 3 multiplies 1. You get this one. 2 times 0 plus 3 times 1. And this also 2 multiplies 3. 3 multiplies minus 2. You get this. And here 2 multiplies minus 5 and 3 multiplies 6. For second row, minus 4 multiplies 0 and 1 multiplies 1. Here minus 4 multiplies 3, 1 multiplies minus 2, and you add. Again here minus 4 multiplies minus 5, 1 multiplies 6, and you add. So this is it. Simplifying this or evaluating this, you will have this one. 0 plus 3 is 3. 6 minus 6, this one is 0. This is negative 10 plus 18, it is 8. This part, this 0 plus 1, it is 1. This part, it's minus 12, minus 2, it is minus 14. The other part, negative 4 times negative 5 is positive 20. 20 plus 6 is 26. So the product of these two matrices is this one. But here, we are also asked to find what? B times A. B times A. To multiply B times A, let's see the size of these matrices. The size of matrix B is this. It has 2 rows and 3 columns, 2 by 3. This it is 2 by 3. And the size of matrix A is 2 by 2. 2 by 2. To evaluate this matrix, the number of columns of the first matrix must be the number of rows of second. But these two are not equal. Since these two are not equal, we cannot evaluate the matrix B times A. So here B is not defined because the number of columns of B is this 3 and the number of rows of A is 2. So we cannot evaluate B times A. Now let's continue. Determinants of 3 by 3 matrix. Here, to define the determinants of 3 by 3 matrix, it is useful to define the concepts minor and cofactors. We need these two things. So let's define these two. Let matrix A is given. Then the minor of ij's entry is given by the determinant of aij, where aij is obtained by deleting the matrix obtained i's row and j's column. So this aij, the determinant of aij is called the minor of the entry aij. Now the cofactor of the entry aij is obtained by this one. The cofactor is obtained by this one, -1 the power of I plus j times the determinant of the minor, that's aij. And as I said, this aij is obtained by deleting i's row and j's column of the given matrix. So let's see this concept through example. We are asked to find the minor and cofactor of 2 and 11 for this matrix. Now, applying the formula to find the minor of 2, first I need to delete the i's rows and the j's column at which 2 is found. 2 is found here. 2 is found here. So the column 2 found, we have these numbers only: -3, -4, -7, 11. So the determinant of this, the determinant of -3, -7, -4, 11, simply here, to find the minor of 2, you delete the row 2 found in the column. Therefore, the remaining part will be this -3, -7, -4, 11. Therefore, the determinant of this will be the minor of 2, the minor of 2. Therefore, calculating the determinant of this, it is -3 times 11 for 2-byte matrix. Simply, I multiply these two, minus, you multiply this. So, minus the product of -4 and -7. So, when you evaluate this, you get -61. Therefore, the minor of 2 is -61. So, to find the cofactor, simply the cofactor of C22 is given by this -1. 2 is found in the second row and second column. So C22 is equal to -1 the power of I plus j is this 2 plus 2, i's row and j's column. So 2 plus 2 times the minor of 2. Therefore, -1 the power of 2 plus 2 is 1 times the minor of 2 is -61. So the answer will be -61. Next, let's see the minor of 11. The minor of 11. 11 is here. To find the minor of 11, what you do is simply you delete the row in the column that 11 found. So the row, you cancel the row and the column. The remaining part will be this -3, 4, 1, and 2. And you take the determinant of this. The determinant of this one is the minor of 11. Therefore, when you evaluate this, -3 times 2 minus 1 times 4, the answer will be -10. Therefore, the minor of 11 is -10. To find the cofactor, simply you multiply the minor by -1 the power in which the row in the column of this function found, the sum of the row in the column. So -1 the power of this is found in third row and third column. So -1 the power of 3 plus 3 times by its minor. Therefore, this equal to -1 the power of 6, it is 1, times the minor of this 11 is this, we are found to be -10. So the product of the two is -10. So now let's see how to calculate the determinant of 3 by 3 matrix. To calculate the determinant of 3 by 3 matrix, first you have to choose any row or column and then multiply each entry by its cofactor. You multiply each entry. First you select any row or column and then you multiply each entry by its cofactor. And then you add up this product. So the determinant will be this, the final result, the sum of the product of the number with its cofactor. So let's see this through example. Here, this matrix is given, and we are asked to find the determinant of this matrix. Find the determinant of matrix A, 2, 1, 0, 1, 1, 4, minus 3, 2, 5. To determine determinant, as we said earlier, you can select any row or column, and then you multiply each entry by its cofactor and add up the products. So let's choose the first row. Just we have chosen this one, the first row. So after choosing this first row, 2 is multiplied by its cofactor, plus 1 is multiplied by its cofactor, plus 0 is also multiplied by its cofactor. So let's see this one. The determinant of A is equal to 2 times. To find the cofactor of 2, simply this found in first row and first column, 1, 1. So negative 1, the power of 1 plus 1 times deleting, the minor will be deleting this row and column, the remaining part will be this part, 1, 2, 4, 5, 1, 2, 4, 5. So 2 is multiplied by, it is cofactor plus, and take 1. 1 times the cofactor of 1, 1 is found in first row and second column. So 1 plus 2, negative 1, the power of 1 plus 2 times by its minor. Minor, simply delete the column in the row, you get 1, negative 3, 4, 5. 1, negative 3, 4, 5. Plus 0 times 0 is found on the first row and third column. So negative 1, the power of 1 plus 3 times its minor. So this will be deleting this column and this row, you'll have this 1, negative 3, 1, 2. So 1, negative 3, 1, 2. Therefore, simplifying this, you'll have this one. The determinant will be this. This is positive 2, and this one is 5 minus 8. And this will be this negative 1, the power of 3 is minus 1 times the determinant of this one, it is 1 times 5 minus 4 times negative 3 plus 0 times negative 1, the power of 4 is 1, so it is 0 times 1 is 0 into the determinant of this 1 times 2 minus negative 3 times 1. Therefore, this will be equal to 2 times this result is negative 5 minus 8, it is negative 3 minus 1 times this will be equal to 17 plus 0 times 5. Therefore, the final result will be, it is negative 23. Therefore, the determinant of this matrix is, it is negative 23. By the way, you can try by using any row or column. For you, please try to check or to find the determinant of this matrix by selecting this column. Select this column and multiply each entry by its cofactor. You will get the same result, negative 23. Check this by yourself. The basic points that we have seen today is to calculate the product of matrix AB. The number of column of A must be equal to the number of rows of B, and the operation is done by row by column in such a way that each element of the row is multiplied by the corresponding element of the column, and then the products are added. And to calculate the determinant of 3 by 3 matrix, simply first you have to choose any row or column, and then multiply each entry by its cofactor, and finally you add up the products. So this gives you the determinant of a 3 by 3 matrix. So this is the basic concept that we have seen today. So for you to try, I will give you questions. Please try these questions by yourself and check your understanding. So this is all about today's lesson. I will give you 1 minute to copy this question So until next lecture class, goodbye.